Hello everybody. Today we're going to be talking about how we could find complex solutions with quadratics. So up till this point, when we've solved using factoring, completing the square root property, or the quadratic formula, if we ended up with like a negative underneath the radical, or we realized that the graph didn't cross the x-axis, we would just say no real solutions. But now we can actually solve for our complex solutions. So remember, if you look at the graph of it and you see that it does not cross the x-axis, that means we're going to have complex solutions. So another thing to remember is that complex solutions always come in pairs. So if you have one complex solution, there's always another one out there. So, but we'll worry more about that when we get to the polynomials chapter. All right, so here's a couple examples. So if you think back to our quadratic chapter, notice these quadratics do not have a b value. Their b value is 0. So the square root property would be the best method to solve these. So let's go through and figure out how we can do this. So with this guy, we want to get the n squared by itself. So we're going to divide both sides by -2. And when we divide both sides by -2, we end up with n squared equals -20. Let me fix my pen. It says it's not skinny. There we go. So now to get n by itself, we've got to take the square root. And whenever we take the square root of a number, we have to do the principal root and the negative root, positive and negative. So now we have n equals positive, negative. So since we have a negative under the radical, we're going to pull that I out, radical 20. So the square root of 20 does have a perfect square in it. So I'm going to write that out. You could rewrite the square root of 20 as the square root of 4 times the square root of 5. And well, the square root of 4 is 2. So our two complex roots would be positive, negative, 2i radical 5. And that would be our answer. All right, so for this next one, we've got to undo any addition or subtraction. So we want to add that 4 to both sides. So now we got 4k squared equals -28. So now we got to divide both sides by 4. Handwriting's exceptionally bad today. So we got -7. Now we take square root of both sides. Again, didn't leave room for my plus and minus, but I'll squeeze it in right there. So that gives me k equals positive and negative I radical 7. And there's no perfect squares in 7. It's a prime number, so that's all we can do. Alright, so notice these examples, they have a b value. So we would have a couple options here. We could use completing the square or quadratic formula, but we focused on the quadratic formula. So we want to get everything to one side. So I'm going to add 9 to both sides here. So now I have b squared minus 2b plus 9 equals 0. So now let's find the value of our discriminant. So our discriminant, remember, is b squared minus 4 times a times c. So that would give us 4 minus 36, which equals -32. So now we need to plug this into the quadratic formula. So we'd have negative b would be a positive 2, plus or minus, I'm going to go and pull my I out, the square root of our discriminant, all over 2 times a, which is 2 times 1. Alright, so we need to simplify that square root of 32 now. So 32 is the same thing as 16 times 2, right? So the square root of 16 is 4. So I'm going to rewrite this to be 2 plus or minus 4i radical 2, all over 2. And now we can see that we have a common factor here of 2, so we can divide all of these by 2. And we would have 1 plus or minus 2i radical 2. That would be our two complex solutions. Alright, so let's do this next problem here. So again, quadratic formula, so we want to get everything to one side. So I'm going to subtract 6x from both sides. And I'm going to add 4 to both sides. So now we have 3x squared minus 6x plus 4 equals 0. So now we got to calculate the value of our discriminants. That would be b squared minus 4 times a times c. So that would give us, that's a d, 36 minus 48. So we got 36 minus 48, that gives us a negative 12. So now let's plug it all in. So we got negative b, which would be a positive 6, plus or minus, I'm going to pull my negative out, I radical 12, all over 2 times a, which is 2 times 3. And again, we can pull a perfect square out of 12, because 12 is 4 times 3. So I'm going to rewrite that. So I've got 6 plus and minus 2i radical 3 all over 6. And again, notice we have that common factor of 2 again. So right here, here, and here. So we can divide everything by 2. So we'd end up with 3, whoops, wrong color. 3 plus and minus I radical 3 all over 3. Wow. And we are done.